So let's start. So what is actually probability, and why this thing we have to learn this thing, why these probability concepts are important in machine learning? So let's see. So first I'm taking the iris dataset. Just I'm taking this iris dataset, iris data that I have taken from the Google image. So first let's understand what is actually the iris dataset. So iris is a set of flowers. That is, iris is a set of flowers. That's a three, mainly they have three kinds of flowers in this set. So first one is versicolor, second one is setosa, and third one is virginica. Mainly they have three kinds of flowers. That's group are called the iris group. That's group called the iris group. So there are three groups: versicolor, setosa, and virginica. And the flowers, the iris flowers, have these type of conditions. These things, that is the flower. This size is called the petal, and this thing, and the shape this that you have shown in these pictures, that this called in the sepal. These things are called the petal, and these things are called the sepal. Similarly, for the petal and the sepal are look like, for versicolors is like that, and setosa, for setosa the petal and the sepal are look like that. The same thing. Just see this thing. Petal and the sepal look like that for setosa, and for virginica the same similar kind of the things. The petal lengths are look like these. The petal things are look like that, and the sepals for virginica are look like that. Mainly for the for petal and the sepals. Based on the petal and the sepals, we have divided these three classes of the flowers. And the thing is that in the data sets that we have generated, that are mainly used these four kinds of lengths. Means first we have taken the petal length. This is the simple petal. This is simple the petal. Here we have taken the petal length, and as well we have taken the petal width. Similarly for sepal, we have taken the sepal length, and we have taken the sepal width. So mainly these four kind of features we have taken to generate our data sets for the classifications of the three groups of flowers. Okay, the first one is petal length, second one is petal width, third one is sepal length, and fourth one is sepal width. And based on these four features, we have classified these three flowers. So now let's look the classes. Let's look the data sets how look like. So this the data set. This is the sample, the structure of the data sets. This picture I am taken from the Google image. You can easily find this data set. Just type on the iris data sets, then you can easily find this data sets. Just I am taking an example. I am taking these examples from the Google image. Okay. So there are the four features, that is sepal length, sepal width, petal length, and petal width, that I have already discussed. Okay, these things. Based on these things, I have built these data sets, and in using these data sets, I have built the classes, each classes. If our sepal length, petal width, sepal length, sepal width, petal length, petal width data sets are look like these, then our class is setosa. Similarly for versicolor also, similarly for virginica also. Thus I am taking the samples of some data. Okay, just for understanding. Okay, just I think you have understand the how look like our data sets is actually. Okay, now the question is why actually we need to study this probability, and why these data sets are important to study the probability. Okay, so let's see. So probability is the simple fundamental concept. This is the first thing, is that in the fundamental area in mathematics. This is the simple fundamental area. This is the simple fundamental area in the topics, fundamental area or topics in mathematics. Number one. Number two, in if you just remember the class 12 And 11th standard we have learning some primary concept of definitions, means what is probability, what is actually these definitions, and how to represent the probability equations, and some applications of the probability like histogram, probability density functions, cumulative density functions, mean, variable, standard deviations, like that kind of things we have already studied in our primary level, that we have learned. And now in this series of lectures, we have learned all the things step by steps and in full details, with and details explanations with and examples. Okay, now let's see step by step. So already we have seen our previous in primary level the concept of histogram, the probability density functions concept, the cumulative density function concept, the mean concept, the variance concept, the standard deviations concept, that things already, and also many things that we have already learned in our primary level. Okay, now we have used this concept to understanding the machine learning and how these things are useful in machine learning. Now the question is, sir, what is probability and why these things are actually important in machine learning? So let's see. So suppose we have taken this data sets, and using these data sets I have drawn then the pair plot. So this is the simple the histograms of the sepal length and the sepal length. Using the sepal length we have using the histograms, and this is the simple the scatter plot. Just let's take this example. Now let's take these examples. I think it will be better for understanding our motto. I think these examples will be best to take on the our. Suppose let's take this example. Here if you just see these things, here the red colors are denoted by the virginica flower, and the green color are just denoted by the versicolor flowers, and the blue color that is denoted by setoja. Just see this picture first. So just if you just closely see this picture, then you can easily understand this thing. Just I am zooming these things for understanding better. Just closely see, just closely if you just see these things, just see this thing. So the blue one is setoja flower. So the blue from these pictures, the blue pictures are well separated from this one, and from versicolor and virginica. From versicolor and virginica, the blue color means the setoja colors are clearly separated. Because why this is one is clearly separated? Just see this picture first. Just see this thing. So the virginica color, the setoja color, just see the setoja color. The petal length and the petal length and the petal length and the sepal length. Just see this thing. Just see the structure of the petal and sepal. These things are the small from the others two. That is versicolor and virginica. And because of these regions, because this petal and the sepal are the small from the versicolor and virginica, because of this it is easily separated. Just see this thing, this petal length and the petal width. Just draw the picture. Petal length and petal width are easily separable. That is a small value from the others two. Now the petal length and the petal width for the petal means what? Petal means this one, petal means this one, and here petal means this one. And but the main thing is these two one, that's distinct look like the similar type of things. Okay, so the question is, if these types of the similar, then sometimes we are be confused. What is the flower? Just look these two flowers, versicolor flower and the virginica flowers. The petal, the size of the petals, and also sepal are look like similar kind. So to distinguish, to classify these two flowers, sometimes we may confused. So to avoid these kind of things, we have used here the probability concept. Now let's see from this scatter plot how probability concept are useful. Let's zoom the picture first. Okay, so just a green one means what? Green one means here the versicolor picture. Versicolor. The green one means the versicolor. This one. I'm talking about this one. And the red one means the virginica. I'm talking about this one. This one. Just see this thing. So these regions, just I'm using the green color. These regions for the Bharsi color, these regions for the Bharsi colors are well separated. And I'm using the gray color for Virginica. And these regions for Virginica are well separated. No problem we have. Till now we have no problem. But the problem is this intercept term. The problem is main problem is this intercept term. So now the question is how to classify this term. Suppose let's take we have a flower, taken a flower that's lie on these regions. That's lie on these regions. Suppose let's take we have taken this flower. Suppose let's take this point is suppose query point. Suppose we have this query point. Suppose let's take this point is xq. xq. This is the query point that we have interested to find what is its actual class level. So we are confused. This query point may be Virginica or these query points may be versicolors. We have not guarantee. So to confusion, such kind of situations, we need the concept of probability. Suppose let's take the petal length. The petal length for this query point is it's near about 5. Suppose let's take 5. And the petal width for this point is suppose let's take this point is 1.6. So if our query point is look like this, then what is the actual class level? So here for these situations we may confused. So to avoid these confusions, we need the concept of probability. So we can easily conclude that. Suppose let's take we have the query point xq, and for this query point, suppose we can say for this query point we may according to our data sets we can find that using the concept of the probability. We can find that. Suppose let's take the probability of the Virginica for this flower is 0.8, and the probability for the Bharsi color for the VE means I am denoted VE for Bharsi color. I have denoted the VE for Bharsi color, and I am VI. I have denoted the VI for Virginica. Okay. Suppose let's take Bharsi color. The probability of the query point is Bharsi color. Let's take 0.8, and the probability of the Virginica. So let's take its value is 0.2. This means what? So this means that our query point, the chance of the query point it will be Bharsi colors is 80%, and the chance of this query point will be Virginica is 20%. This is the main thing. Means here we have not properly. I am not considering the query point is Virginica or it may be Bharsi colors. I am taking some chances according to our data sets. According to our data sets, we have taken some chances here. How much chances our query point it will be Virginica, or how much chances it will be Bharsi color. So using this type of concept here, we need to define the probability. Here the probability concept are useful. Also we have seen in various real in nature everything has linguistic, everything is a qualitative. We cannot properly quantify everything in nature. This is the main natural thing in our environment. So in such scenario we need the concept of probability to distinguish such kind of confusions using the concept of probability. I think you have understood why the probability concept is useful. Okay. And we can conclude that here also 80% chance, here also 20% chance, and we can easily conclude that here for the setosa its probability is 0, means 0% chances, because it is well separated. We have not to worry about this term. The main thing is this. I think from these examples, from the construct of examples, you have already learned, we have already understand, you have already understand the concept of the probability, how these things is important, or why we need to learn, and let's see these things step by step. Why actually these things are important. Suppose let's take, I've taken another examples for better understanding. Suppose let's take, we have taken an example, dice, throwing a dice. So if you just throwing a dice, they are have the six sides of the dice. Just six side of the dice. We have already known the side of the dice is a six side, and each sides are denoted by a number. 1, 2, 3, 4, 5, and 6. Each sides are denoted by a number, through a number. And if you throw a dice, if this die is if these dice are equally likely, then the every points occur for the every points are equally probable. Okay, so they have any, if you throw a dice, they have equally chance to occur any of this point. So this time, if you just job this, if you doing these jobs, roll a fair dice. If you throw a fair dice, we have to, if we doing these jobs, then main the concept is fair. If this is not fair, then our probability are not equally probable, means are not equally likely. So because these our dice fair dice, so the chances are equally likely. Equally likely because of this because our dice is fair, because of this. So here we have the random variable x. So doing these jobs, suppose let's call these job are only random variable. These things are random variable. Let's call these random variables, and the random variables are denoted by the sample, the outcome of this performance. So if you're doing these jobs, what will be the outcome? Outcome will be 1, 2, 3, 4, 5, 6. So the value of this x will be, so the value of the x will be 1, 2, 3, 4, 5, and 6. This is the value, simple value of this random variable. And these jobs are simple, the experiment, that the thing that we have done using these dice, that's are called the random variable. Simple, I'm taking an examples by using. So they have another kind of, suppose let's take, we have taken another kind of example. Suppose let's take, we have taken the tossing a coin. Tossing a coin. If we're doing the experiment tossing a coin, and we have already know for a coins there have two sides, such for a dice there have six sides, for a coin there have two sides. So the sides are head or tail. If we're taking a pair coin, so the random variable, let's take the doing tossing a coin, a random variable y. So what will be the outcome of this random variable? Head and tail. This is the another example of a random variable. I think you have understand the concept of the random variables. So simple, the random variable is an experiment that take the outcome of these experiments. The random variable is a sample and experiments that take the output value of that experiment. Okay, simple. This is the simple definitions. Okay, this is the simple. This is the simple means languagically definitions of a random variables, but the notations of mathematical notations are like this. Suppose just suppose let's take, we have doing this experiment dice rolling a fair dice. So our experiment is rolling a fair dice. Rolling a fair dice. And we call this thing as the random variable x. And the random variable will, as definitions of the random variable, these random variables are takes the value. This random variable takes the value between 1 to 6. Random variable is an experiment that take the value, the output of that experiment. And because of that, x is a random variable rolling a dice, and this takes the value this. Okay, now we are interested because we have taken a pair dice. So each output, the occurrence of the each output is equally probable. So what will be the value of this thing? What will be the value of the random variable x? It's occur 1. What is that? Because this is a paired die, total we have 6 points, 6 outcomes. As the definitions of the probability, total we have 6 outcomes. So our denominator will be 6 and the numerator, how much point 1 we have? We have 1. The probability of the random variable x occur, the occurrence of the random variable 1, the probability is 1 by 6. Similarly for x is equals to 2, 1 by 6. So h points are equally probable. Sorry, 1 by 6. Okay. Now the question is, suppose let's take, I am doing the experiment. Suppose let's take we have defined. Suppose let's take we have defined the our experiments like this. X. Suppose let's take we call this x dash. X dash is the occurrence of the even points. For rolling a dice, we are interested to find the even points. Even points. So rolling a dice. Rolling a pair dice. Suppose this is the our x dash frame. So in this random variable, what will be the output? What will be the output? Random variable, what will be the output? Let's see. So output will be, we are interested to find this event. X is equals to now we are interested to even points, means output will be 2, 4, 6. And simple, if you just see the if you just based, this is our the based on this experiment, what will be the probability of this experiment? So the probability of x is equals to x test. Our experiment x means rolling a fair dice and it will occur the only even points based on this. So these things will be total point, we have how much? We have total point 6, and on this 6 point, how much occurs the x stats? Only 3 times. So these points will be 1 by 2. Similarly, if we just consider the odd point, similarly instead of taking the even point, if we take the odd point, what will be the probability? Similarly same things, because we have 1, 2, 3, only 3 points for odd point. So this probability will be 3 by 6. That is 1. Same thing. Now the questions is, just if you taken the suppose let's take, I have taken the interest to find the even points. Okay, so how much point? Just compare these things step by step. Suppose we have how much even point? How much even point we have? Only 3 even points, 2, 4, 6. So instead of writing this, we can write this thing. Only we have 3 even points. Probability of, so to find the events points means we have probability of x is equals to 2 plus probability of x is equals to 4, also plus probability of x is equals to 6. These are the 3 events that we have interest to find for this event x dash. So we already know that probability of x is equals to t is what? 1 by 6. 1 by 6 is 1 by 6. We just sum up, then we can also get the same answer. So this is the another way to find the probability of an experiment. Now various times, in many times, we have, instead of using x for a random variable x, the outcome will be x1. This probability means the probability of the random variable x of it will be x1. So its meaning is the symbolical meaning. The symbolical meaning is the probability of random variable x, probability of the random variable x when its output is x1. Okay, or in generally in generally we have written these things instead of repeating these things. We have in generality x probability of x1. Okay, both the same things are equal. Okay, don't be confused, both the same. These things and these things are both the same things, but just instead of writing these things again and again, we have simply use these things, these notation. This is a simple language meaning is the probability of a random variable x when its output is x. This is the simple its meaning. Now suppose let's take we have designed another random variable. Suppose let's take we have designed another random variable, height of a student. Height of a randomly picked student. Randomly picked student. This is the main thing. Randomly picked student. We have picked a random student from a class, and we are interested to find its height. So what will be the how these things for in such situations and probability is why the probability concept are important. So let's say suppose let's take in generally in humans human heights are lies between in generally humans heights are lies between 120 centimeter to 190 centimeter. In generally we have seen this the humans are lies in this range. Suppose let's take we have taken a random students in a class, and this is the simple our random variable. Let's take it's the random variable y. So we have taken first we have randomly picked a students from a class, and suppose let's find we have this distance. Suppose let's take 162.55. And another thing is suppose let's take instead of writing this one, so okay, no problem. Now again in the next experiment we have picked another students, and suppose let's take we have find its students 132.62. so just see this thing in previous cases is that means that the thing is that for these cases height of a picked students the lies between 120 centimeter to 190 centimeters, and its value could be anything between these ranges. It could be 120.5, 120.6, 120.5555666. Any value means any value between in this range. So because of these things, this kind of random variables are called the continuous random variable. Continuous random variable. But here, you see these things. Here we have done the experiment, rolling a fair dice, and just we have rolled it, and there have only 6 chances. Only 6 chances. It may be 1, 2, 3, or 4, 5, 6. But we can count these outcomes. But here we cannot count these outcomes. Because of that, these kind of outcomes are called the discrete random variable. This kind of random variables are called the discrete random variable. Discrete random variable. But here we cannot count this kind of outcome. We cannot count the outcome of this kind of random variables. Because of that, this random variable are called the continuous random variable. And the concept in this concept of random variable, there have a very important concept we need to find the very important concept, the concept of outlier. So why these things are important? Suppose let's take we are doing the experiment. Why? That experiments are designed such like that height of a student. Height of a student. Okay, we are designing this experiment, and these experiments, the outcome of these experiments are look like that. Suppose let's take our output will be look like that. We have doing this job, we have taken the height of the students from a class. Suppose let's say we have taken the 50 students for a class. Suppose first height is 120.2, 146.9. Suppose let's take the dot up to 3.6 156.99. Suppose let's take we have taken the 50 students example. As an example, 50 we have randomly picked 50 students and have taken the data, height data of each students randomly picked. So the height data is look like that. Suppose just see this thing, just see this number, just see this number, just see this number. So in general we have seen that our data the if you using the height of a human, the data look like lies between this range. But here instead of this range, we have taken this range look like 12.26. This is very means uncertain range. This is the uncertain data. So this kind of data are called the outlier. And the outlier of this data set, the outlier of these data sets may occur because of some observations. Suppose those who have count this the height of this data, so by chance they have doing some mistakes. Suppose instead of writing 22.6, they have writing these numbers. So this kind of outliers may occur because of some observations error. It may be some observations error, it may be some count error, it may be some human error. There are various kind of errors. It is so because of some these errors, our data sets there have some outliers. Now how to find this kind of outliers? What kind of statistical tools we have to find this? So we have already known the concept of probability. Now the thing is how the statisticals comes into the pictures to the world of probability, to the world of machine learning. Okay, just see this thing, just see the example. So here we have doing the some mistakes for these data sets for the to build this data set height of a random students. So we have doing this kind of errors, observations, the account error. Actually the data sets are built by human, and humans are not machines or not a god. They are have, it is obvious things, and they have some errors. So these kind of errors are called the outliers. Now the question is how to find this kind of errors. So there have some statistical tools. So we have already learned in our primary level in class 12th 10th standard, we have already learned these things. Are example the mean, we have already done the concept of variance. If you just find this data set, mean of this data sets, then if you find the mean or variance for this data set, so using this, if you just take this data 12.26 instead of 22.6, the mean of these data sets have changed dramatically. So these two kind of statistical tools cannot handle the outlier, So to avoid these things, we have already developed the median concept that can easily doing this job, handle the outlier. That can easily do. Already in the next part of these lectures, we have seen these things, how to handle using such kind of statistical tools, or how to handle the outlier, how to handle this kind of data sets, how to design equally as our requirement. That we have seen step by step in very details using the examples, and also we have using the Python code to see this data sets lively. Okay, just don't be confused how to design and how to handle, how to find the outlier, how to design the build a models. We have seen everything in full detail step by step. Okay, just patient with me and stay tuned with this series of lectures. Okay, so I think from these lectures you have got some simple idea how the probability and statistics are useful in the whole machine learning, in the whole world of machine learning. I think using these iris datasets, you can easily understand the importance of statistics and probability.